Welcome back, students. In the last lesson, we learned about power in an AC circuit, real power, reactive power, and apparent power. Now, the big question is, where do we actually see all of this in real life? In our homes. Look around your house. Almost everything you use runs on AC power. Your bulb, your fan, your fridge, and even your phone charger. That's real power in action. When you switch on a bulb, it lights up because of real power. This is the useful energy doing actual work. Now, let's look at reactive power at home. Think about your ceiling fan. It contains a motor, and motor needs magnetic field. That's where reactive power comes in. It helps build and maintain that magnetic field. So even though you don't see it, reactive power is quietly doing its job behind the scenes. Why power factor matters at home? If your home has many devices like fans, ACs, and refrigerators, the power factor reduces. What does that mean? More current flows, wires get hotter, energy efficiency drops. So even at home, power factor affects how efficiently electricity is used. Now, let's move to factories, where this concept becomes very serious. Industry use heavy machines like motors, transformers, and welding machines. All of this draws a lot of reactive power. The problem is that this leads to low power factor, and that causes energy losses, overheating, and higher electricity bills. So what do engineers do? They install capacitor banks. Capacitor helps cancel out the effect of inductors, improving the power factor. Now let's talk about how electricity travels from power station to your home. Electricity moves through long transmission lines. If power factor is low, current increases, heat losses increases, voltage drops. That's why engineers always try to keep power factor close to 1. At power stations, generators don't just supply real power. They supply apparent power S. So they must handle both real power P and reactive power Q. If reactive power becomes too high, generators get overloaded. The system becomes unstable. Let's take a simple example, a water pump. For the motor to work, real power makes it rotate. Reactive power creates magnetic field. Without reactive power, the motor won't even start. Remember the power triangle from the last lesson. It helps engineers to calculate efficiency, reduces losses, and design better system. The smaller the angle phi, the better the efficiency. Let's make it super simple. Imagine you are walking forward carrying a bag, moving forward, real power, shaking side to side, reactive power, total effort, apparent power. The more you shake, the harder your journey becomes. So students, AC power is not just a theory. It affects everything from your home appliances to massive power stations. If you enjoyed this lesson, don't forget to like, share, and subscribe. And in the next video, we will look at resonance in AC circuits.